want you to imagine your morning commute for just a second.
Oh, yeah, the absolute best part of the day, right?
Right. But I don't mean the idealized version. Not the one where the roads are magically clear and your train is exactly on time. I mean the real exhausting commute.
The bumper-to-bumper traffic, the packed subway cars, the endless waiting.
Exactly. I want you to think about the sheer amount of time you spend, day in and day out, just trying to translate your physical mass through space.
It's a massive sink of human hours when you really add it up.
It really is. But now imagine stepping into this sleek, this little enclosure right in your living room. The door seals behind you, the ambient noise drops to zero, and instantly, without a single second of transit time, you step out into your office.
Just completely bypassing the traffic.
Yeah, or you blink, and you're standing on a sun-drenched coastline halfway across the globe. You know, the salt air is already in your lungs.
It sounds like pure magic.
It does. But this isn't just the stuff of speculative fiction anymore. I mean, it is the ultimate human aspiration, right? The total erasure of distance.
Yeah, it really is. It's the absolute asymptote of human logistics. I mean, when you remove the friction of space, you completely redefine the geometry of human civilization.
You change everything.
Exactly. We've essentially spent our entire history trying to flatten the physical world. We're always trying to bring the latency of movement closer and closer to zero.
Which makes sense.
Right. It's a concept that speaks to a very fundamental human frustration. Our consciousness feels completely unbounded, but it is tethered to a physical substrate, our bodies, that is maddeningly trapped by geography.
We are stuck in the meat, so to speak.
Yeah, exactly. Trapped in the meat.
Well, we are not just going to talk about the romance of that idea today. We have a massive stack of source material for this deep dive. We're pulling from research papers, physics monographs, and some amazing excerpts from a book called Bridging the Void, The Science and Paradox of Teleportation.
It's a fantastic collection of sources, very rigorous.
Super rigorous. And our mission today is to unpack the brutal, unforgiving physics standing between us and that instant commute.
Because there is a lot standing in the way.
A lot. We are going to figure out what the math actually permits, where the engineering hits an absolute wall, and what is secretly genuinely terrifying about the mechanics of instantaneous travel.
Oh, the terrifying parts are my favorite.
Right. Okay, let's unpack this, starting with why we even view teleportation as an inevitable technological endpoint rather than just, a magic trick.
Well, if you look at the macro trend of human civilization, it's essentially a long war against the spatial dimensions.
A war on distance.
Precisely. We move from terrestrial friction, walking and riding animals, to maritime logistics with ships.
Like conquering the oceans.
Yeah. And then to aerodynamic lift with planes. And finally, we hit the speed of light with global data networks. We reached a point where information practically ignores distance entirely.
Right. Like a packet of data hits a server in Tokyo from New York in milliseconds.
Exactly. So the cognitive dissonance comes from the fact that our data can teleport, but our actual bodies are still moving at the speed of a jet turbine, at absolute best.
I mean, our digital avatars, our capital, our voices on calls like this, they all have zero travel time.
The world is flat for information.
Exactly. We've essentially been compressing the map for thousands of years. Teleportation isn't really a new idea. It's just the final, ultimate map compression. It eliminates the journey entirely.
That's a great way to put it. But this is where the human mind naturally assumes that the physical map just has to eventually follow suit, right?
We assume technology will just figure it out.
Right. But the sources are quick to point out that this is where we run headfirst into what we might call the universe's red tape.
The red tape of reality.
Yeah, because the rules governing information and the rules governing baryonic matter, the stuff we are made of, are fundamentally different regimes.
Right. They don't play by the same rules at all.
They really don't. We tend to extrapolate the exponential growth of computing power onto physical mechanics. We just assume Moore's law will eventually figure out how to beam a human being across the planet.
Just put a better processor in the transporter pad.
Exactly. But the universe enforces incredibly strict constraints regarding mass energy equivalence, causality, and quantum determinism.
You can't just hack physics.
No, you really can't. You cannot simply bypass spatial coordinates without paying a profound thermodynamic and informational toll.
Yet, I mean, we constantly see headlines claiming, like, scientists successfully teleport a particle. I read one just last week on my feed.
Oh, I see those all the time.
It makes it sound like the red tape has already been cut in the lab, right?
Yeah.
If we are teleporting photons and electrons over hundreds of kilometers right now, Why is the jump to a larger mass, like a person, so impossible?
Because those headlines, while they are based on astonishing, very real science, are heavily leveraging a sort of linguistic sleight of hand.
A bait and switch.
Yeah, a total bait and switch. They are referring to quantum teleportation, and that is rooted in a phenomenon that early 20th century physicists literally spent decades arguing over.
Which is quantum entanglement.
Yes, quantum entanglement.
Is that the thing Einstein hated? The famous spooky action at a distance.
That's the exact quote, yeah. Einstein called it spooky action at a distance because he was deeply unsettled by it.
Why did it bother him so much?
Well, in quantum mechanics, if two particles interact in a specific way, their quantum states become mathematically inseparable. They basically share a single wave function.
Even if you pull them apart.
Exactly. If you measure the spin or the polarization of one particle, the universe instantly forces the other particle into a corresponding state. And that happens even if they are separated by an entire galaxy.
Which means they're communicating faster than light.
Well, that's the tricky part. It implies a non-local correlation that totally defied the classical understanding of how influence propagates through space. Einstein thought nothing could go faster than light, so this instant link drove him crazy.
Okay, so how are experimental physicists today actually using that non-local correlation to teleport something? Because you said they've done this over 1,000 kilometers with satellites. Walk me through the mechanics of a modern teleportation protocol.
All right, let's break it down. We usually conceptualize this in physics using two imaginary observers, standardly named Alice and Bob.
Good old Alice and Bob.
Always Alice and Bob. So Alice holds a particle, let's say it's a photon, and she wants to transfer its exact quantum state to Bob, who is hundreds of kilometers away.
Okay, so she has the target package.
Right. But to do this, Alice and Bob must first share an entangled pair of ancillary photons.
Wait, ancillary, so there are more particles?
Yeah, Alice has one half of the entangled pair, and Bob has the other half.
Okay, I'm following. So there are 3 particles in play here total. Alice's original target particle, and then these 2 entangled ones acting as a sort of bridge between them.
Yes, exactly, a bridge. So the next step is Alice performs a joint measurement on her original target photon and her half of the entangled pair.
She measures them together.
Right. In physics, this is called a Bell state measurement.
And this is where the magic happens.
This is where the physics happens, and it's highly counterintuitive. By performing this specific joint measurement, Alice forces her 2 particles into a combined state.
Okay.
And because her entangled particle is fundamentally inextricably linked to Bob's particle miles away, this measurement instantly alters the state of Bob's particle.
Wait, so Bob just instantly has the target particle? It's done.
No, and this is the crucial catch that the headlines always gloss over. Bob's particle has been altered, yeah, but it isn't a perfect replica yet.
It's like half-baked.
Sort of. Alice's measurement yields a classical result. It literally just spits out 2 bits of ordinary classical data, a 0 and a 1, basically.
Okay, just normal computer data.
Right. And she has to send those 2 bits of data to Bob using a conventional light-speed communication channel, like a laser pulse, a radio wave, or a fiber optic cable.
Oh, so she essentially just texts him the result of her measurement.
Effectively, yes, she texts him. And when Bree receives those 2 classical bits, they act as an instruction manual for his particle.
An instruction manual.
Yeah. He applies a specific quantum gate operation, like a phase shift or a rotation to his particle, completely based on Alice's message.
And then what?
Once he does that specific operation, his particle assumes the exact identical quantum state of Alice's original target photon.
Okay, I have to stop you there. I am tracking the math, but I'm feeling incredibly betrayed by the terminology here.
I don't blame you at all.
I mean, nothing physically traversed the gap.
Yeah.
Alice's original photon didn't fly through the air. The only thing that crossed the distance was a standard light-speed text message.
Yep.
The actual matter stayed put, and just the quantum vibe or blueprint moved to Bob's particle. That feels like false advertising.
It is a profound semantic disconnect between physicists and the general public. You are absolutely correct. The quantum state moves, the physical matter does not.
It's completely different than sci-fi.
Totally different. Quantum teleportation transfers the information encoded within a quantum system. The physical stuff, the substrate itself, remains strictly local.
So we're basically teleporting the software and just forcing remote hardware to run it.
That is an excellent way to frame it. The hardware doesn't move. Also, Alice's original particle is completely scrambled by her measurement. its initial state is destroyed.
So you lose the original.
Yes. And Bach's particle was already sitting in his laboratory the whole time. It merely had its properties reconfigured to mimic Alice's original perfectly.
I mean, it's an incredible achievement for building a quantum internet or like unhackable cryptography.
Oh, absolutely revolutionizing those fields.
But it's not a transportation mechanism. It's an alignment mechanism.
Precisely.
And the source material argues that scaling this up from a single photon to a macroscopic object like trying to teleport a human listener right now isn't just a matter of building a bigger machine. We run into a catastrophic bottleneck with the data itself.
The data requirement is where the concept of human teleportation hits its first insurmountable wall. I mean, it's a staggering wall.
Let's talk about the scale of that data.
Well, if you want to transfer a human being using this method, you aren't just sending a generic mass of carbon and water. A pile of ash has carbon and water.
Right. We want the person alive.
Yes, you are dealing with an exquisitely precise arrangement of matter. The average human body contains approximately 10 to the 28th power atoms.
10 to the 28th. I can't even conceptualize a number with 28 zeros.
It's beyond human comprehension, really.
To put that in perspective for you listening, if every single atom in your body was just a single byte of data, we are talking about a data volume that vastly exceeds the total storage capacity of the entire global internet.
By billions of times over.
Billions. Just to store the data of one person. And we aren't just logging what element each atom is, right? Like this one is carbon, this one is oxygen. We need its full quantum state.
Exactly. We need its exact position, its momentum, its spin, its vibrational state, and crucially, how it is entangled with the atoms around it.
Because life isn't static.
Right. Biological systems are not static sculptures. They rely on incredibly delicate, dynamic chemical reactions.
Like neurons firing.
Yes, membrane potentials, protein folding mechanisms, all of these things happen on the quantum level. To reconstruct a conscious human, you theoretically need the perfect quantum blueprint of all 10 to the 28 constituent parts at a frozen moment in time.
But physics actively forbids us from getting that blueprint, doesn't it? Like we can't just take a high-resolution snapshot of an atom.
No, we can't. And that is because of the Heisenberg uncertainty principle.
Right, the uncertainty principle. Explain how that blocks us.
Well, it's the fundamental limit on measurement precision in the universe. Werner Heisenberg demonstrated that conjugate variables, like the position and the momentum of a particle, cannot both be known with arbitrary precision at the same time.
It's a trade-off.
A strict mathematical trade-off. The more accurately you measure where an atom is, the more uncertain its velocity becomes, and vice versa.
And just to be clear, this isn't because our microscopes are bad.
Exactly. It is not an engineering limitation of our sensors. You could have a flawless sensor built by aliens. It is a fundamental property of wave-like quantum systems. The universe doesn't allow that information to exist simultaneously.
It's like trying to take a perfectly sharp photograph of a hummingbird's wings. I mean, the faster the wings beat, the blurrier the photo gets.
That's a great analogy.
Thanks. Except here, the universe itself physically refuses to let you focus the camera on both the position and the motion at the same time. You want a crisp image of the atom's location? Fine, but now you have no idea where it's going.
You're completely blind to its trajectory.
Right. You want to know its trajectory? Fine. But now its current location is just smeared across a probability wave.
And this ties directly into another terrifying roadblock, a concept known as the no-cloning theorem in quantum mechanics.
The no-cloning theorem, what does that say?
It mathematically proves that you cannot create an identical copy of an arbitrary unknown quantum state.
You can't just copy and paste an atom.
No. The very act of measuring the state in order to copy it collapses the wave function. It irrevocably alters the original state.
Wow. So a perfect, non-destructive scan of a human is mathematically impossible.
Completely impossible.
So to extract the data required, doesn't just read your data. It inherently obliterates the specific quantum configurations that make you, you.
Yes. You cannot separate the measurement from the destruction of the original state. You are essentially flying blind.
Because of the blurry lens.
Right. The blurry lens of quantum mechanics means your instruction manual, your text message to Bob, will always be incomplete or corrupted at the fundamental atomic level.
Okay, let's play devil's advocate here. This is a deep dive. Let's push past the impossible and see what's on the other side of this problem.
All right, I'm game.
Let's imagine a theoretical future where we invent some miraculous workaround. A Heisenberg compensator, to borrow the sci-fi term.
Love the Star Trek reference.
Had to do it. So let's say we successfully scan every atomic state perfectly. We extract all the data without losing coherence, and we store it on some unfathomably dense theoretical black hole hard drive.
Okay, giving ourselves a huge pass on the physics there.
A massive pass. But we have the 10 to the 28 atoms perfectly mapped. The data is safely in Paris. Now we actually have to build the physical body on the receiving end.
Right, the assembly. And this transitions the problem from quantum information theory, which is hard enough, into civilization-scale thermodynamics and manufacturing.
So we have a massive reservoir of raw elements waiting in Paris. Vats of carbon, oxygen, hydrogen, nitrogen.
Just a sludge of life's building blocks.
Yeah, organic sludge. And we have to arrange them. But we are not talking about advanced 3D printing here, are we?
Not even close. Even the most sophisticated additive manufacturing we have today operates on a macroscopic geologic timescale compared to what a teleportation assembler would need to do.
If the 3D printer just squirts plastic layer by layer.
Exactly. A teleportation assembler would need to manipulate matter at the angstrom scale in 3 dimensions, all simultaneously.
To build a human.
Yes. It has to perfectly weave together hundreds of billions of neurons, establishing the exact synaptic weights and neurotransmitter concentrations that house your memories of what you ate for breakfast.
It has to physically construct memories.
Yes, it has to construct thousands of miles of capillaries and trillions of cellular membranes, all in a fraction of a second.
And it has to, like, press play on the biology perfectly.
What do you mean by press play?
Well, you can't just build a cold, static meat statue of a person and then hit it with a defibrillator to wake it up.
Oh, absolutely not.
The biological engine has to be actively running during the assembly process. The cellular respiration has to be active. The action potentials in the brain have to be cascading. Otherwise, you just arrive dead.
That is horribly accurate. Which brings us to the thermodynamic nightmare: entropy and heat.
I knew heat was going to be an issue.
It's the ultimate issue. Assembling a highly ordered, complex system like a living human body from chaotic raw materials in a fraction of a second requires a massive localized decrease in entropy.
Going from chaos to extreme order instantly.
Exactly. And according to the laws of thermodynamics, that process will generate an apocalyptic amount of waste heat.
Apocalyptic. How much heat are we talking about here?
If you attempt to chemically bond 10 to the 28 atoms into complex organic molecules almost instantaneously, the sheer thermal energy released by those chemical bonds forming...
It would get warm.
Warm. It would literally vaporize the receiving pod, it would melt the building it's housed in, and likely level a significant portion of the surrounding city.
You're joking. Just from making the chemical bonds.
Just the heat of assembly. You would need cooling systems operating on a scale that basically defies planetary engineering.
That is insane.
Yeah.
And that's just the heat of assembly? What about
Yeah.
the actual energy required to drive this entire process in the first place?
Ah, the energy bill.
Right, because if we are breaking down a physical body in New York and somehow synthesizing mass from pure energy in Paris, we run directly into Einstein's mass energy equivalence, don't we?
We hit the E equals mc squared barrier head-on.
E equals mc squared, the most famous equation in the world.
And the most punishing in this context. Mass and energy are simply different manifestations of the exact same physical property. But the c squared part, the speed of light squared, is an astronomically large constant.
So a tiny bit of mass equals a ton of energy.
Exactly. Consequently, a small amount of mass represents a terrifying reservoir of energy.
Let's do the math on this. If we look at a standard, say, 70-kilogram human body,
An average adult.
mass energy bound up in that matter,
Yeah.
what is the equivalent?
It is essentially the equivalent of a multi-gigaton nuclear arsenal.
A multi-gigaton nuclear arsenal. Just sitting in my chair.
Yes. It is roughly equivalent to the total energy consumption of a major industrialized nation over several years.
Wait, really?
Truly. If the New York teleporter deconstructs your mass and attempts to transmit it as a directed energy beam to Paris, you are quite literally firing a weapon of mass destruction through the atmosphere.
Oh, wow. So we aren't just dealing with an IT technician problem here. Moving a giant zip file across the globe is the least of our worries.
The least of them.
We would have to become civilization-scale energy gods just to power a single commute. We would have to become like a Type I Kardashev civilization just to afford the power bill to teleport a CEO to a business meeting.
The source material is adamant about this. Teleportation is persistently mischaracterized in pop culture as a communications technology.
Like a fancy telephone.
Right. When in reality, it is the ultimate heavy industry thermodynamic crisis.
My brain is already milking from the sheer violence of these physics. But I want to push forward into what I think is the most unsettling part of our source material today.
The philosophy.
The philosophy.
Yeah.
Let's assume infinite energy. Let's assume miraculous cooling towers that save Paris and perfect quantum scanners that don't blur.
Okay, a perfect magic machine.
Right. You step into the machine in New York. The machine scans you perfectly. It deconstructs your physical form to extract the data. It beams the data to Paris. And the assembler there perfectly recreates you from local sludge.
And you step out.
You step out in Paris, fully intact. The question the sources ask isn't how did the machine work, but who actually just stepped out.
Yes. And now we are leaving the realm of physics entirely and entering the deep, very dark waters of philosophy of mind and neurobiology.
The identity paradox.
Exactly. This is the identity paradox, and it revolves entirely around the concept of the continuity of consciousness.
Let's look at the physical result first.
Yeah.
The person stepping out of the pod in Paris is an exact atomic-level duplicate.
Flawless.
They have your exact neural pathways. Therefore, they remember your childhood. They remember drinking coffee that morning. They remember stepping into the pod in New York.
They have your specific fear of spiders, your exact sense of humor.
They truly, subjectively believe, down to their very core, that they are you.
And from an external perspective, like, if I am your colleague waiting for you in Paris, the machine worked perfectly. You arrived, we go get coffee, you reference a conversation we had yesterday, your behavior is perfectly continuous.
I passed the Turing test of being me.
Easily. For all intents and purposes, in a social and legal framework, you are the original person. This aligns with a philosophical view called patternism.
Patternism, meaning you are just a pattern.
Basically, it argues that you are simply the pattern of information, not the actual physical meat substrate. If the pattern is preserved, you survive.
Okay, here's where it gets really interesting and, frankly, highly disturbing. Let's look at the subjective internal experience of the person in New York.
Right, the person who stepped into the pod.
If we subscribe to physicalism, which is the idea that consciousness is tied to a specific, continuous biological existence, then the pattern isn't enough, is it? The physical continuity was broken.
It was shattered. If consciousness is an emergent property of your specific continuous biological hardware, then the moment the scanner in New York ripped your constituent atoms apart to measure them, your stream of consciousness permanently ended.
Permanently.
Yes. The original, you experienced a total permanent cessation of existence.
Death. You died.
Yes, you
Yeah.
died in New York. The entity in Paris is a newly born replica, burdened with your memories, convinced of its own continuous existence, but the subjective observer that walked into the New York pod is gone forever.
And the ultimate proof of this horror is found in the no-cloning workaround we mentioned earlier.
How so?
Well, earlier we talked about how reading the exact quantum state destroys it. But let's say we abandon quantum perfection. Let's say a macro-level biological scan is good enough for teleportation. It leaves you functionally identical, even if a few stray electrons are different.
Okay, a non-destructive scan.
Right. If you can scan the body without destroying it, then the process finishes, the door opens, and the original you steps out of the New York pod completely fine. You're still in New York.
And then you look at a monitor.
And you watch your exact copy step out of the pod in Paris.
That is the ultimate thought experiment that shatters the teleportation illusion.
Completely shatters it. In that scenario, it is blatantly obvious that the original subject did not travel anywhere. You are still standing in New York looking at a screen. The machine merely assembled a clone in France,
A perfect replica.
which means the destruction protocol in the New York pod vaporizing the original body isn't a mechanism of transportation at all.
It's an administrative cleanup process.
Yes. It's just destroying the evidence so the universe doesn't fill up with duplicates. It is literally a replication and murder machine.
A harsh way to phrase it, but philosophically sound.
Every single time you commute, you commit suicide, and a clone inherits your life, your bank accounts, and your family.
Yeah.
Totally oblivious to the fact that they are just a facsimile that was born 5 seconds ago.
What's fascinating here is that there is absolutely no empirical way to test which interpretation is true. None. No instrument can detect the subjective internal transfer of a continuous soul or stream of consciousness. Science cannot measure subjective experience. The debate between patternism and physical continuity remains completely fiercely unresolved in the philosophical and neuroscientific communities.
Well, I can tell you right now, I am never stepping into one of those pods.
I don't blame you.
Even if the technology is completely perfected and safe, a 50% chance that I am just a disposable clone stepping over the vaporized ashes of the guy who woke up this morning. That is a hard deal breaker for me.
It fundamentally reframes the technology from a miracle of modern convenience to an existential roulette wheel.
Yeah, no thanks. So, if disassembling the body is a thermodynamic nightmare, a WMD threat, and an existential murder crisis, is there a way to cheat this system?
Cheat it how?
Can we leave the biological substrate completely intact? Can we completely avoid the atomic data crisis, avoid the WMD energy levels, and just move the intact person from A to B?
Well, that requires abandoning the quantum approach entirely and zooming way out to the macroscopic mechanics of the universe. We have to look at general relativity.
Einstein again.
Einstein again. If moving matter through space is too energetically costly, the alternative is to manipulate the geometry of space itself.
Okay, so we're talking about warping the metric tensor.
Yeah.
Bending the board instead of moving the piece.
Exactly. Bending the board. Einstein's field equations describe space-time not as a static, empty theater where events just sort of take place, but as a dynamic, malleable fabric.
Like a trampoline.
Sure, a trampoline. Mass and energy warp this fabric, which we experience locally as gravity, but theoretically, with the exact right distribution of energy, that fabric can be pinched, stretched, or even stitched together.
Which leads us to the concept of Einstein-Rosen bridges.
Oh.
Or, as everyone calls them, wormholes.
Oh, yes, wormholes.
I want to avoid the tired old visual of taking a piece of paper, drawing two dots, and folding it in half with a pencil poke through it. We've all seen that in a dozen movies.
It's a bit played out.
Let's try a different mental model from the sources. Imagine space-time is a vastly complex digital tapestry.
Right.
Like a massive matrix of computer code determining what spatial points are adjacent to each other.
Okay, I like that.
A wormhole isn't necessarily a physical glowing tunnel you fly a ship down. It's more like executing a command that dynamically rewires the topology of the matrix. It takes 2 points separated by billions of lines of code or thousands of miles and temporarily assigns them the exact same coordinate value.
That is a much more rigorous analogy. You are altering the topological connectivity of a universe itself.
You're hacking the map.
Exactly. If a stable, traversable wormhole were created with one mouth in your living room and the other mouth in Paris, the distance through the throat of the wormhole could literally be a matter of meters.
Just a single step.
Right, while the distance through normal, external space remains thousands of kilometers.
So you just walk through a threshold. Your atomic structure isn't scanned. Your wave functions don't collapse into a blurry mess. And your continuity of consciousness is perfectly preserved because you never died.
You're just walking through a weird door.
Exactly. It solves the thermodynamic WMD problem and the murder clone paradox simultaneously.
It does solve the biological and philosophical problems, yes, but it introduces astrophysical engineering problems that are arguably even more severe.
Oh, come on. I sense an incoming... But why can't we just warp the space-time metric and open a door?
Because the math allows for the theoretical existence of wormholes, but the physical universe violently, actively resists their formation and stability.
Violently resists.
Yes. The first major obstacle is stability. The equations indicate that a naturally forming wormhole would collapse on itself almost instantaneously. The gravitational forces would pinch the throat shut before even a single photon of light could traverse it.
Let alone a human.
Right. To pry the throat open and to keep it stable enough for a macroscopic object like a person to pass through safely, you require a highly specialized, localized gravitational repulsion.
You need something to push back against the gravity crushing it.
You need what theoretical physicists call exotic matter.
Exotic matter. What makes it exotic?
Well, this isn't just an undiscovered element on the periodic table. It is matter that possesses a negative energy density.
Negative energy.
Yes. It thereby violates the null energy condition of classical physics.
Wait. Negative mass. How does something have less than zero mass? If I hold it, does it push my hand up?
It is entirely counterintuitive. It pushes away instead of pulling. And while we do observe subtle microscopic quantum effects like the Casimir effect that mimic localized negative energy densities in a vacuum, generating and isolating macroscopic usable quantities of exotic matter to prop open a human-sized wormhole, well, it might be fundamentally forbidden by the deeper laws of quantum gravity.
So even if we figure out the math to open the door, the universe might just say, sorry, the building materials you need for this project are permanently out of stock. They don't exist.
That's a very real possibility. Furthermore, even if you acquired the exotic matter somehow, the very act of a particle or a person entering the wormhole could trigger a catastrophic feedback loop.
A feedback loop, like a microphone squeal.
Sort of, but with quantum vacuum fluctuations. They could circulate through the wormhole, piling up on themselves infinitely, round and round, until the sheer energy density destroys the wormhole entirely.
So the shortcut violently detonates the very moment you try to use it.
It collapses the instant you try to cheat distance.
That really seems to be the running theme here.
Yeah.
The universe actively, violently defends its spatial dimensions against us.
It's a heavily guarded prison of geometry.
So if true, physical teleportation, whether by disassembling and cloning our atoms or by ripping forbidden holes in the metric tensor, is either mathematically forbidden, energetically suicidal, or centuries away. Does that mean the dream of eliminating the commute is dead? Are we just bound to our geography forever, sitting in traffic?
Not necessarily, and this is where the sources make a fascinating pivot. We have to shift our perspective from fundamental physics to pragmatic, lateral technological evolution.
Lateral evolution.
Yes. Throughout history, when humanity encounters an absolute, unbreakable physical limit, we don't always break the limit. We usually invent a lateral substitute that achieves the exact same subjective utility.
Oh, right. Like if you look at the history of flight, for centuries, humans tried to fly by, strapping feathered wings to their arms, desperately trying to mimic the biological mechanics of a bird.
And ornithopters' flapping wing machines turned out to be a complete engineering dead end for human transport.
Because we aren't birds.
Right. We lacked the necessary power-to-weight ratio and the biological musculature. If we had stubbornly insisted that true flight required flapping wings, we would still be stuck on the ground today.
Instead, we shifted paradigm.
Exactly. We utilized fixed airfoils, aerodynamic lift, and eventually combustion engines. We invented airplanes.
The airplanes don't fly the way birds fly at all,
Yeah.
but they solve the problem of aerial transport beautifully. They get us in the air.
So the question the text asks is, what are the airplanes of teleportation?
If disassembling matter is the flapping wing, what is the fixed wing substitute that actually gets us across the globe instantly?
The source material posits that the practical substitute for physical teleportation will be the ultimate mastery of human perception and presence.
Perception and presence.
Yes. We are looking at the convergence of neurotechnology, ultra-low latency data networks, and remote robotic avatars.
Subjective teleportation.
Exactly. Subjective teleportation. The human brain's perception of being somewhere is entirely dictated by the sensory inputs it receives. Sight, sound, touch, proprioception.
They're all we are.
Right. If you can perfectly hijack those specific inputs, the actual location of your physical body becomes entirely irrelevant to your subjective experience.
Okay, let's visualize this for the listener. Imagine you need to inspect a facility in Tokyo, but you are sitting in your living room in London.
A brutal flight.
The worst. But you don't step into a terrifying deconstruction pod. You sit in a comfortable, specialized chair, slip on a high-bandwidth, non-invasive brain-computer interface, a BCI, and your consciousness is instantly routed to a synthetic, anthropomorphic avatar waiting in Tokyo.
And this avatar isn't just a clinky drone on wheels with an iPad for a face. It is equipped with advanced neuromorphic sensors.
Meaning it feels like human skin.
Yes. The moment the avatar touches a steel surface in Tokyo, the tactile feedback is transmitted with millimeter wave precision directly into your somatosensory cortex in London. You literally feel the cold texture of the steel.
Wow.
The acoustic environment of the Tokyo room is piped directly into your auditory processing centers. You hear the hum of the machines as if you are standing right next to them.
No, wait. The latency would have to be incredibly low, right? To avoid motion sickness, I get dizzy in current VR headsets if there's a slight lag.
Latency is the main engineering hurdle, yes. But if the data is traveling at the speed of light through fiber optics or advanced satellite arrays, the round-trip ping time between London and Tokyo is only a few dozen milliseconds.
That's barely noticeable.
Barely. And the human brain is incredibly plastic. It would likely adapt to that microscopic lag almost instantly, seamlessly integrating the avatar's mechanical body as its own. It would just feel normal after a few minutes.
If we connect this to the broader trajectory of our current technology,
Right.
this is not science fiction at all.
Mm.
Haptic feedback suits, brain-machine interfaces like Neuralink and remote teleoperation are highly active, massively funded fields of research today.
They are accelerating rapidly. Once the sensory fidelity crosses a certain threshold, the cognitive illusion will be absolute. For all intents and purposes, your mind, your agency, and your presence have teleported.
And you bypass the thermodynamic nightmare entirely.
Yeah.
You don't have to violate the Heisenberg uncertainty principle.
Yeah.
You don't have to harvest impossible exotic matter. You maintain total biological continuity, avoiding the murder clone paradox completely. You achieve the exact, objective, instantaneous global travel by transporting the consciousness through a digital medium, while leaving the heavy, problematic, fragile physical substrate safely parked at home in your living room.
It is a vastly more elegant solution to the problem of distance. But, and I must caution this, even this easier path requires an unprecedented synthesis of disciplines.
It's not happening tomorrow.
No. We need quantum networking to ensure the massive data streams have zero packet loss and total cryptographic security. We need massive breakthroughs in material science to create synthetic muscles and hyper-realistic haptics.
In neuroscience,
Yes, we need neuroscience to fully, flawlessly decode the language of the human sensorium.
so the source material is remarkably sobering about the timeline here. We aren't going to have seamless avatar teleportation next decade. It requires simultaneous revolutions across physics, biology, and computer science.
We are fundamentally in the position of early astronomers. We have finally figured out how to build a rudimentary telescope, and we can clearly see the planets. We understand the orbital mechanics, we know the destination exists, but the heavy engineering required to actually traverse the void remains hidden behind centuries of rigorous, compounding scientific discovery.
Which brings us to the end of a truly mind-bending deep dive today. Let's map out the sheer scale of the terrain we just covered.
We covered a lot of ground.
We started with the universal desire to erase geographic friction and immediately collided with the universe's strict physical laws. We dissected the reality of quantum entanglement, realizing that while spooky action at a distance is very real, it only transfers state information.
Right, it's a cosmic alignment of software, not a transportation of hardware.
Exactly. We then faced the terrifying mathematics of the data crisis. We saw how the Heisenberg uncertainty principle strictly forbids us from ever reading the perfect atomic blueprint of a human being.
The blurry lens.
The blurry lens. We realized that even if we could somehow cheat that quantum law, assembling 10 to the 28 atoms perfectly would require localized cooling systems and energy outputs that rival nuclear arsenals, literally threaten to incinerate the destination.
A literal weapon of mass destruction for a commute.
Then we stared directly into the abyss of the identity paradox, coming to the chilling realization that a perfect atomic scanner that destroys the original body is functionally indistinguishable from an existential murder and clone machine.
A philosophical nightmare.
Truly. We searched for a loophole in general relativity, hoping wormholes could fold the metric tensor of space-time, only to discover they require theoretical negative mass and might instantly collapse into a fiery quantum foam the second we try to use them.
The universe says no.
The universe says no. And ultimately, we concluded that while the universe vigorously defends its physical dimensions against biological matter, we might achieve the exact same dream through the back door of perception.
Subjective teleportation.
Right. Using low-latency networks and advanced neurointerfaces to project our consciousness globally, rendering our physical location completely obsolete.
It's an incredible lateral move for humanity.
The sheer tenacity of human curiosity is staggering. We are a species bound to gravity and strict thermodynamics, yet we can sit here and mathematically model the parameters of our ultimate escape from those confines.
It's what we do best.
So, what does this all mean? It means that our current understanding of the physical world is just a prologue. The deeper we analyze a concept as seemingly fantastical as teleportation, the more intimately we understand the rigid, unyielding, and utterly beautiful scaffolding of our reality. The actual future of human logistics won't look like a 1960s sci-fi television show. It will be governed by deep quantum mechanics, relativistic topology, and the absolute limits of thermodynamics. But I want to leave you, the listener, with one final lingering question to turn over in your mind. It builds on that last concept we explored, the neural interfaces and the global projection of presence. If one day a synthetic avatar allows your mind to perfectly inhabit a space 10,000 miles away and you feel the warmth of the sun and the texture of the ground with absolute flawless clarity without your physical biology ever moving an inch from your living room, did you teleport? Or are we slowly marching toward the realization that the conscious you actively listening to this right now was never permanently attached to your physical body in the first place?